polar graph with 10-degree increments from 0 to 360 degrees. In mathematics, the polar coordinate system is a two-dimensional coordinate system that includes a point on a plane that is determined by a distance from a fixed point and an angle from a fixed direction. The fixed point is called the pole. The ray from the pole in the fixed direction is called the polar axis. The distance from the pole is called the radius, and the angle is called the polar angle. The polar angle is also called theta. The polar coordinate is represented by r and theta. Pole with a radius of 9 at a 60-degree polar angle from the polar axis. When a Cartesian coordinate, or xy, is given, this can be converted into a polar coordinate, r and theta. Also, the polar coordinate can be converted into a Cartesian coordinate. The formula to convert from polar to Cartesian is x equals r times the cosine of theta, and y equals r times the sine of theta. The example is convert the polar coordinate with a radius of 6 and 50 degrees into Cartesian coordinates. X equals 6 times the cosine of 50 degrees. X equals 3.8567. Y equals radius 6 times the sine of 50 degrees. After that is calculated, y equals 4.5963. The point, when rounded, 3.9 and 4.6, is the Cartesian coordinate of the polar coordinate, radius 6, 50 degrees. To convert from polar coordinate to Cartesian coordinate, the radius equals the square root of x squared plus y squared. Theta equals the inverse tangent of y divided by x. The example, convert Cartesian coordinate 3.8567 and 4.5963 to polar coordinate. The radius equals the square root of 3.8567 squared, which is 14.9, plus 4.5963 squared, which is 21.1. After adding those two together and taking the square root, the radius comes out as equaling 6. For theta, you take the inverse tangent of 4.5963 divided by 3.8567. After that is calculated, theta equals 50 degrees. When dealing with polar coordinates and Cartesian coordinates, the protractor is the tool for you to use. This is a small poem that I added just for fun. Protractor providing provisions to please, procuring precisely measured degrees. Protracting protractor, providing the angles, measured each time, rays and rectangles. Protractor providing measures with ease, providing me angles of measured degrees.